Section 2.3 is about hypothesis testing. So we introduce this concept here, and we'll get into a lot more details with it further in the semester. The first learning objective is to explain the logic of hypothesis testing. So just the thinking behind what's going on when we're doing a hypothesis test. This first example says the p-value for the test is 0.0169. State whether this is statistically significant for each alpha level. Let's first define what statistically significant means. Statistically significant means that the p-value is less than the alpha that you are given. So this is what statistically significant means. So let's look at our first alpha level, 0.01. A p-value of 0.0169 is greater than 0.01, and so that means it is not statistically significant. A p-value of 0.0169 is less than an alpha of 0.05, so in this case, we do have statistical significance. The next example says, a facilities manager at Salt Lake Community College believes that his supply of light bulbs has too many defects. The manager's null hypothesis is that the supply of light bulbs has a defect rate of P equals 0.07, the defect rate stated by the light bulb manufacturer. Suppose he does a hypothesis test with a significance level of alpha equals 0.05. Symbolically, his null and alternative hypotheses are H naught, P equals 0.07, and HA, P is greater than 0.07. That P stands for the population proportion. In this case, it's the proportion of all light bulbs that are defective. So the p-value is given to be 0.087, and we need to choose the correct interpretation for this p-value. The definition of a p-value is the probability of observing the sample results that we obtained or more extreme ones if the null hypothesis is true. So let's look at A. The p-value tells us that the probability of concluding that the defect rate is equal to 0.07 when in fact the rate is greater than 0.07 is approximately 0.087, which is an unusual outcome. So first of all, there are several things in here that tell us it's incorrect. First of all, it gives us a probability of 0.087, which is greater than the alpha level of 0.05 that we were given above. And so therefore, this is something that is a higher probability than our cutoff value. So that is not an unusual outcome. Other incorrect things in this answer is that the p-value tells us the probability of our sample results, not the claimed null hypothesis results. And the p-value is based on if the null hypothesis is true. So not if, in fact, the rate is greater than 0.07, which is the alternative hypothesis, but if the rate is equal to 0.07, which is the null hypothesis. So let's see if we can find a better answer. B says the p-value tells us that if the defect rate is 0.07, then the probability that the manager will have 27 or more defective light bulbs out of 300 is approximately 0.087. At the significance level of 0.05, this would not be an unusual outcome. Okay, so here we have if the defect rate is 0.07, that's stating if the null hypothesis is true, so we're off to a good start. We want the probability of the sample results or more extreme. Well, here are some sample results. 27 or more defective light bulbs out of 300. So 27 or more says sample results or more extreme. And then there's our probability value. So that's the correct definition of a p-value. And since that p-value is greater than 0.05, that is considered not an unusual outcome. Remember that an unusual outcome would have a low probability. There's our correct answer. Let's look at C and D just so that we can make sure that we are clear on this concept. C says the p-value tells us that the true population rate of defective light bulbs is approximately 0.087, so the facilities manager is correct to believe that his supply of light bulbs has too many defects. So remember that the p-value is not giving us the true population proportion, it's giving us the probability of observing the sample results that we saw or more extreme results if the null hypothesis is true. And then D says none of these. Well, we know that B is correct. All right, let's look at the last example about the thinking behind hypothesis testing, and we'll get into more details in further learning objectives on the specifics about hypothesis testing. So this last example says, if the p-value for a hypothesis test is less than the significance level, which of the following is a true statement? So if the p-value is less than alpha, which is our significance level, then which is true? The probability that the alternative hypothesis is true is small, so we should accept the null hypothesis. Well, first of all, we never accept the null hypothesis. We either reject it or fail to reject it. B says the p-value gives the probability that the null hypothesis is true, so a small p-value means that the null hypothesis is certainly false. No, as we just discussed, the p-value gives the probability of observing our sample results or more extreme results if the null hypothesis is true. Let's look at C. The observed results are very unlikely under the assumption that the null hypothesis is true, so we should reject the null hypothesis. Getting a p-value less than the significance level means that our results are unusual or unlikely. And remember that the p-value is computed assuming the null hypothesis is true. So when that p-value is less than alpha, when we have statistically significant results, that's when we reject the null hypothesis. So C is our correct answer. Let's look at D just to be complete. The observed results are very unlikely, so there was probably an error in the data collection process. Well, we can observe unlikely results if the null hypothesis is false, and that's likely what happened. Hopefully there wasn't an error in the data collection process. We've already talked about how to collect data well, and we will assume that that was done here.